Okay, so we're all pretty familiar with relational databases, right? Neat rows and columns, all that good stuff.
Right.
But today we're diving into something much bigger.
Literally.
Haha. Yeah, big data.
Yeah.
Huge data sets that are basically just exploding in our world. And as you can probably guess, the security challenges they bring are...
Well, they're pretty interesting. Let's put it that way.
Definitely. So to set the scene, think about this.
Okay.
Relational databases, they were at least built with some security in mind from the start.
Yeah, that's true to an extent.
But big data solutions, especially those early ones built on Hadoop, they were all about handling massive amounts of data, first and foremost.
Right. Speed and scale were the priorities.
Exactly. Confidentiality, not so much.
It was almost like building a giant library, but forgetting to put locks on the doors.
I like that analogy. So now you've got mountains of data, potentially really sensitive information spread across a ton of servers.
Yeah.
Where do you even begin to secure something like that?
Well, that's the million-dollar question, isn't it? The sheer volume, the velocity of data in these big data environments, they create security challenges that are totally unique.
Okay, I'm listening.
Imagine a data lake, right? It's basically a vast pool of raw data within a Hadoop system.
Okay, I can picture that.
Now picture multiple fire hoses just constantly pumping information into this lake, some of it structured, some of it not.
Oh, it's a lot of data.
It is.
Yeah.
And trying to control access and filter out all the noise, it becomes a monumental task.
I bet. And to make things even more chaotic, it sounds like the initial focus in big data was all about functionality.
Yeah, pretty much.
The security aspects like confidentiality, they kind of took a back seat.
Exactly. And that's led to a lot of add-on security features being developed, which sometimes feel like a bit of a Band-Aid solution.
I see.
Oh, and to add another layer of complexity, we can't forget about the cloud.
Right.
More and more organizations are relying on cloud platforms, whether it's public or hybrid, and that adds a whole other dimension to securing these big data environments.
So it's like we're trying to secure this overflowing data lake while also dealing with leaky pipes and a constantly shifting foundation.
You got it.
It sounds like we need a multi-layered approach
Yeah.
to even stand a chance, kind of like fortifying a castle.
Exactly. We need to think about data at rest, data in transit access control, and a whole lot more.
Okay, let's start with data at rest.
Okay, so picture this data just sitting on a hard drive in our giant data lake.
Okay, got it.
One crucial measure is encryption. Encrypting that data makes it unreadable to anyone without the decryption key.
Makes sense. So it's protected even if someone manages to get their hands on the physical drive.
Exactly.
So encryption sounds essential, but are there different ways to encrypt data at rest?
Oh, absolutely. There are a bunch of different encryption algorithms, each with their own strengths and weaknesses.
Okay.
Choosing the right one depends on a lot of factors, like how sensitive the data is and what kind of performance impact the encryption and decryption will have.
You mentioned performance impact. Does encryption slow things down?
It can, but with modern hardware and efficient algorithms, that impact can be minimized these days.
Okay.
It's always a trade-off between security and speed, though. You need to find the right balance for your specific needs.
Right. So we've got encryption to protect data at rest. What about data in transit? I mean, data isn't just sitting still in these environments. It's constantly moving between nodes or to and from the cloud.
Right. You're thinking about data on the move. And that's where secure data transfer protocols come in, things like SSL and TLS.
Okay.
These protocols basically create an encrypted tunnel for the data to travel through, so it stays confidential while it's moving across the network.
It's like transporting valuable goods in an armored truck.
Exactly.
And I imagine just like with encryption at rest, there are speed and efficiency considerations here too.
Absolutely. In the big data world where we're dealing with huge amounts of data moving really fast, we need transfer solutions that are both fast and secure.
Right, so it can't be like a slow-moving convoy with a heavy escort.
Haha, exactly. Products like Asper Signet and File Catalyst have come up to address this specific need. They often use UDP with parallel TCP validation to speed things up.
Interesting. So we've talked about securing data at rest and in transit, but what about controlling who gets to access the data in the first place? It's like we've built our fortress, but now we need guards at the gates.
Precisely.
Yeah.
And one of the key players in the Hadoop world for that is Kerberos.
Kerberos. Okay, I've heard of it.
It's a tried and tested authentication protocol. It's used in a lot of enterprise environments.
Right.
And it provides a very robust way to verify the identity of users and services that are trying to access the Hadoop cluster.
So Kerberos is like the guy checking IDs at the door, making sure everyone who's trying to get in is actually who they say they are.
Pretty much. But then the next question is, what are they allowed to do once they're inside?
Right, because it's not enough to just let anyone in. We need to control what they can access and what they can do with the data.
Exactly, and that's where authorization comes in. Hadoop has some basic security features like file permissions to control access at the file level.
Okay.
But as we've been discussing, those may not be enough in more complex big data environments.
Right, because we're not just dealing with files anymore. We have these massive data sets spread across multiple servers, and we need more fine-grained control over who can access what.
Exactly. And that's led to the development of more enhanced security products like Cloudera Sentry, DataStax Enterprise, and DataGuys.
Okay.
These tools offer much more granular control over data access. You can set up permissions based on roles groups and even specific data elements within a data set.
So it's not just about locking the library doors. It's about having different levels of access for different areas within the library and even controlling who can read specific books on the shelves.
Precisely. We need access control mechanisms that operate at all these different levels, from file permissions and node access to schema-level restrictions.
I see. So we can make sure that users can only access the data they're actually authorized to see, even within specific data sets or tables.
Exactly. That's the goal.
Okay, so we built our fortress, we have guards at the gates, and we've got a system for checking IDs and granting access. But even with all that, we still need to keep an eye on things, right? It's like having security cameras and guards patrolling the perimeter just in case.
Absolutely. Auditing and monitoring are crucial in big data security, especially in a distributed system like Hadoop where data is spread across multiple nodes.
Right.
Pinpointing vulnerabilities or suspicious activity can be really challenging. So we need robust auditing tools that can track data access modifications and any unusual behavior across the whole cluster.
It's almost like having a detective constantly investigating for clues. But with the sheer volume of data and activity in a big data environment, that must get really complex.
It definitely can. That's why we need specialized tools that can analyze these massive audit logs, identify patterns, and alert us to potential threats.
So it's not just about collecting logs. It's about making sense of them and using that information to actually improve our security posture.
Exactly. And that's where things get really interesting, because now we're talking about analyzing huge amounts of data to identify security threats. It's like using big data techniques to secure big data itself.
Now that's meta.
Right.
Okay, so we've covered a lot of ground in this first part of our deep dive.
We have.
We've talked about the unique security challenges that come with big data environments, the importance of securing data at rest and in transit, and the role of access control mechanisms like Kerberos.
Yeah.
We even touched on the critical need for auditing and monitoring in these complex distributed systems.
It's a lot to consider, but it's all connected.
Definitely. So much more to unpack, though.
Absolutely.
So it's like we've built this impressive fortress, got our guards at the gates, and a whole system for checking IDs and managing access. But is that really all it takes to secure a big data environment? It seems like it would be a constant battle.
You're not wrong. It definitely requires ongoing attention. And one area that's often overlooked, but super important for long-term security, is data archiving and purging. Remember our data lake analogy?
Yeah.
Well, it's not meant to be a bottomless pit. We can't just keep hoarding data forever.
Right. That makes sense. Holding on to data longer than necessary probably increases storage costs and also makes you a bigger target for attackers.
Exactly. Holding on to all that data just expands your attack surface. So we need clear strategies for archiving data that's not actively being used and purging data that's reached the end of its life cycle.
So it's like decluttering our data warehouse and securely getting rid of anything we don't actually need.
Yeah.
But how do you decide what to keep and what to discard?
It's a good question, and it depends on a few factors: legal and regulatory requirements your business needs, and the sensitivity of the data itself. Like, if you're dealing with healthcare data, there are regulations like HIPAA that might require you to retain it for a specific period.
So compliance plays a big role in data retention policies. And I imagine that gets even more complex when you factor in different regulations across different regions and industries.
Oh, absolutely. You've got PCI DSS for payment card information, GDPR in Europe, and a whole bunch of other regulations to keep track of. And when your big data system spans multiple countries or uses the cloud, it can be a real headache trying to stay compliant with all of them.
It's almost like you need a legal team just to manage data retention.
Sometimes it feels that way.
But even with all these measures in place, encryption, access control, auditing, archiving, wouldn't all this security stuff impact performance? I mean, big data is supposed to be all about speed and agility. Wouldn't all the security just slow things down?
It's a valid concern. Security and performance can sometimes feel like they're at odds. But remember, security isn't just about building impenetrable walls. It's about finding the right balance between protection and usability.
So it's about finding that sweet spot where you have strong security, but you're not sacrificing the speed and flexibility that makes big data so powerful.
Exactly. And that brings us to best practices for securing Hadoop clusters, which are really at the heart of many big data environments.
Okay, so let's dive into those best practices. What are some key things organizations should focus on when it comes to securing their Hadoop clusters?
Well, first and foremost, they need to move beyond the basic Hadoop security features and embrace more comprehensive solutions. As we've talked about, features like file permissions, they're a good starting point, but they're often not enough for the complex security needs of big data.
So layering on additional security measures is key. But what kind of measures are we talking about specifically?
Think about encryption for both data at rest and in transit robust access control mechanisms with really fine-grained permissions and, of course, thorough auditing and monitoring capabilities.
We've touched on those throughout our conversation, but can you give us some concrete examples of tools and technologies that organizations can use to actually implement these security measures?
Sure. For encryption, you've got tools like Apache Ranger and Cloudera Navigator Encrypt. They offer a range of encryption options so organizations can choose the level of protection that fits their needs and their risk tolerance.
And what about access control? We talked about Kerberos for authentication, but what about authorization and managing those really detailed permissions you mentioned?
For that, you have tools like Apache Sentry and Cloudera Access Control. They provide that granular control over data access, so administrators can define policies based on roles groups and even specific data elements within a data set.
So it's like having a highly customizable security system for your data fortress. But it seems like managing all these different tools and technologies could be a challenge in itself.
It definitely can be. That's why it's crucial to have a centralized security management platform. It gives you that unified view of your security posture across the entire Hadoop cluster.
So a single pane of glass to monitor and manage all the security controls.
Exactly. Platforms like Cloudera Manager and Hortonworks Data Platform offer some really robust security management capabilities so administrators can configure, monitor, and audit security settings, all from a central location.
That sounds like it would simplify things a lot. But even with all the right tools and technology in place, security isn't just about that, is it? There's the human element to consider as well.
Absolutely. Even the most secure system in the world can be compromised by human error or malicious intent. That's why security awareness training is so important for everyone who interacts with the Hadoop cluster.
So making sure that everyone understands the importance of data security, knows the best practices for handling sensitive information, and can recognize and report potential threats.
Exactly. It's about creating a culture of security where everyone feels responsible for protecting the organization's data. And it's an ongoing process. It requires regular training updates to keep up with all the evolving threats and the latest security best practices.
Speaking of evolving threats, the big data security landscape is constantly changing. New vulnerabilities are discovered. Attackers find new ways to exploit them. How can organizations even hope to stay ahead of the curve?
Staying informed is absolutely crucial. They need to keep up with the latest security advisories, patches, and best practices. Regularly updating their Hadoop distributions and security tools is paramount.
So just like we keep our computers and smartphones updated, we need to do the same for our software and security defenses when it comes to big data.
Precisely. And another important step is penetration testing and vulnerability assessment.
Those sound intense.
They're basically controlled exercises where you simulate real-world attacks to try to identify weaknesses in your system before an actual attacker can exploit them.
So it's like hiring ethical hackers to try to break into your fortress and then using their findings to strengthen your defenses.
You got it. It's a proactive way to identify and mitigate vulnerabilities.
So it sounds like securing a big data environment is not a one-time fix. It's an ongoing journey.
It absolutely is. And it requires a comprehensive approach that includes the technology, the processes, and the people involved. But by embracing best practices, staying informed, and fostering that culture of security organizations can effectively protect their big data assets and unlock its full potential.
So building a secure and resilient big data environment, It's a team effort that involves everyone from the developers and data scientists to the security professionals and business leaders.
Exactly. And it's an effort that requires constant vigilance adaptation and a commitment to staying ahead of that ever-evolving threat landscape.
And speaking of staying ahead of the curve, you mentioned earlier this initiative called Project Rhino that's focused on enhancing security for Hadoop. Can you tell us a bit more about that?
Sure. Project Rhino is basically a collaborative effort within the big data community to address some of the key security challenges we've been discussing.
So it's like a collective push to strengthen the whole Hadoop security framework. What specific improvements are they working on?
They're focused on areas like improving encryption key management, establishing a common authorization framework, and enhancing audit logging across the entire Hadoop ecosystem.
Okay, let's break those down a bit. What are they doing to improve encryption key management specifically?
They're working on providing a more robust and secure way to manage the encryption keys that protect our data. It's like adding a master key to our data vault, making it even harder for unauthorized access.
Makes sense. And what about this common authorization framework? How will that help?
Remember how we were talking about the need for granular access control and managing permissions for all those different users and groups? Well, Project Rhino is aiming to establish a standardized way to handle authorization across all the different Hadoop components.
So streamlining and standardizing authorization. Okay,
Yeah.
that makes sense.
Okay.
And I imagine enhanced audit logging is a priority as well.
Absolutely. They're looking to improve the way Hadoop tracks and logs user actions to provide more detailed and comprehensive audit trails. It helps us understand who did what, when, and where, which is crucial information for both security and compliance.
It's like having a much more sophisticated security camera system with better recording and playback. You can go back and review the footage in much greater detail to investigate anything suspicious.
Exactly. And these are just a few of the areas that Project Rhino is tackling. It's an ongoing initiative, so we can expect to see even more advancements in Hadoop security as the project progresses.
So it's encouraging to see the big data community coming together to address these security challenges head on.
Yeah.
It seems like they're really trying to bake security into the framework from the ground up rather than adding it as an afterthought.
That's exactly the shift in mindset we need, because as big data becomes even more integrated into our lives, think personalized healthcare, smart cities, all of that, the security stakes are just getting higher and higher.
It's exciting to think about all the possibilities, but also a little bit scary when you consider the sheer amount of data that's out there and how much it can reveal about us.
Which is why this whole conversation is so important. Ultimately, big data security is about more than just protecting information. It's about maintaining trust. Trust that organizations are handling our data responsibly, ethically, and securely. If we lose that trust, the potential of big data could be severely limited.
So as we move further into this world of big data, we need to find that balance between harnessing its power for good and making sure that we're doing it in a way that protects individual privacy and security.
Exactly. It's a delicate balance, but an absolutely crucial one. The future of big data depends on it.
It really is a delicate balance, and the responsibility is huge, especially as big data becomes so integrated into our lives.
Right. As we wrap up this deep dive, it's important to remember that this conversation about big data security never really ends.
Okay.
The landscape is always shifting. New threats pop up. Technologies keep advancing.
So for our listeners who are trying to navigate all of this, what are some of the key takeaways they should really keep in mind?
I think the biggest takeaway is that big data security isn't a one-size-fits-all kind of thing. It's all about understanding the specific challenges of your environment, the kind of data you handle, the technologies you use, the regulations you have to comply with.
Makes sense. So you can tailor your security approach to your specific needs.
Exactly.
So assess your risks, figure out your needs, and then build a security framework that actually addresses those specific points.
Exactly. Don't just try to apply some generic set of rules because it won't be as effective.
And you've mentioned this before, but that multi-layered approach is key, right?
Absolutely. You want to incorporate all those different security measures we've talked about: encryption, access control, auditing, archiving, purging.
It's like having a security onion with all those different layers of protection.
Haha. I like that analogy. And just like peeling back an onion can make you cry sometimes, navigating the complexities of big data security can feel just as overwhelming.
I bet. But as we've seen, it's absolutely necessary to protect those valuable data assets.
It really is.
And this is something we touched on in the last part, but it's worth repeating. Security isn't just about the technology, it's also about the people.
It's a team effort for sure. You need to foster a culture of security awareness where everyone understands their role in protecting sensitive information and follows those best practices.
So processes and a security-conscious workforce are just as important as the tech itself.
Exactly. You need all three working together. And of course, you need to stay vigilant, constantly monitoring, adapting your security posture to address new threats and vulnerabilities as they come up.
So always staying one step ahead.
As best you can. And as big data becomes even more integrated into our lives, personalized healthcare, smart cities, you name it, the importance of security is only going to grow.
That's true. Big data has the potential to change so many things for the better, but that potential also comes with risks.
Right.
It's our responsibility to make sure that we're harnessing the power of big data safely and responsibly, protecting individual privacy and the security of organizations.
Couldn't agree more.
So as we wrap up this deep dive, I want to leave our listeners with one final thought. As we keep moving further into this world of big data, how do we strike that balance between innovation and security? How do we create a data-driven society that embraces progress, but also protects what needs to be protected?
That's the question, isn't it? The future of big data really hinges on our ability to build that trust and make sure these incredibly powerful technologies are being used ethically and responsibly.
I think that's a great note to end on. Big data offers so many incredible opportunities, but it's up to all of us to make sure those benefits are realized securely and responsibly. Thanks for joining us on this deep dive. Until next time.